Hi, welcome everybody. This is Mrs. Dunn. I've created this screencast to talk to you about estimating a population mean. What I'm going to be covering in this screencast is I'm going to be talking about or answering the questions, what are the requirements for constructing a confidence interval for the population mean? What is a student t-distribution? And how do I find the critical values for a t-distribution or a normal distribution? And when do we use the student t-distribution and when do we use the normal distribution? Okay, so let's get started talking about what requirements do we need. So if you saw my previous screencast, in that screencast, we were estimating a population proportion. Now we're estimating a population mean. So we're going to be constructing a confidence interval for that population mean, and we have to have a few requirements. The data that we are using to construct this confidence interval has to be normally distributed. So we have to look at the data and see if it has that general bell shape. If it has that general bell shape, then we can actually construct that confidence interval for the population mean. Now, what if the data is not normally distributed? Well, if the data does not have that normal shape, but we have enough data and enough data for what we're going to be using in this text or for our class, it means that we have a sample size that's greater than 30. So if we have a sample size that's smaller than 30, but the shape is that general bell shape, then we can construct a confidence interval. Or if our sample size is greater than 30, then we can construct a confidence interval for the population mean. Okay, so those are the requirements: normal distribution or a sample size greater than 30. Now, in this section, to estimate this population mean, sometimes we're going to be using what is called the student t-distribution. And the student t-distribution is used because it allows for more varying, for more variance when that sample size is kind of small. So what I want you to do is I want you to look at this graphic that I have here in the PowerPoint. So in green, you can see the standard normal curve, or that standard normal distribution. And the red and the blue curves represent the student t. One thing I want you to notice is the blue one is the student t distribution when n is small, when n is equal to 3. And when n is equal to 12, it actually has a different shape. So you notice that it definitely has that general normal curve, but it doesn't match up perfectly. So the student t-distribution has the same shape as a normal distribution, but the standard deviation is 1. There's more variance. The standard deviation is greater than 1, okay? What's important for you to understand is that that standard deviation changes with the number of data in the data set. So as the number of data gets bigger and bigger and bigger, the student t-distribution is getting closer and closer to the standard normal distribution. So the student t-distribution is different for different sample sizes. So in this section, when we're told to use the student t-distribution, which we're going to talk about on the next slide, when do I use student t, when do I use normal? I'm going to answer that question. But if we're asked to use the student t, we need to know what that sample size is. We need to know that because the value we use for the critical values is going to be different depending on what that sample size is. So in this section, we talk about something that's called the degrees of freedom. And the degrees of freedom is 1 less than the sample size. So this abbreviation DF for degrees of freedom is equal to n minus 1. Hopefully this will all become clearer at the end of this screencast where we go through quite a few examples. Okay, now we've talked about the student T, and we've talked about the normal distribution already in this class. So when do we use the student T? When do we use the normal distribution? This chart from your textbook explains it perfectly. This is a nice little chart to look at. But basically what you want to focus in is, do you know sigma? Sigma, remember, is the population standard deviation. Do we know it? So if sigma is not known, and those other constraints are satisfied, meaning that we either have a normally distributed population or we have a sample size that's greater than 30. So if we don't know sigma, n is greater than 30 or normally distributed, we're going to use the student T. If we do know sigma, if we know the population standard deviation, then we're going to use the normal distribution. The truth is, you very, very rarely know the population standard deviation and not the mean. If you know the population standard deviation, then you probably know the population mean, and none of this would be necessary. Okay, now, if the population is not normally distributed and less than 30, there's another method that's called bootstrapping that's covered in another section in your book, which we are not going to be covering in this course. All right, so let's look at some examples. First, what we're talking about here is, should we use the T distribution, the normal distribution, or neither? So what I'm going to do is I'm going to go through a few examples, okay? If we need to use the T distribution, then we will find the critical values for the T distribution. If we're going to use a normal distribution, we'll find the critical values for the normal distribution. And we'll talk about whether or not we should use either of those distributions. So look at this example. So this is an example. In this example, we have 17 Miami Heat salaries represented in this graphic. So these are the questions that we want to ask. Is this data normally shaped? Does it have a bell curve? No, it does not. Is this sample size bigger than 30? No. And do we know the population standard deviation? No. The answer to all those questions are no. And since it's not normally shaped and n is not greater than 30, then we can't use the T distribution and we can't use the normal distribution. We don't know sigma. So the answer to this is neither. So we cannot construct a confidence interval for the population mean for this problem. Okay, let's look at another one. So these are Denver Bronco salaries. And here we have this graphic represents the salaries for 61 players, and their salaries are shown in thousands of dollars. But we have 61 players represented here. So even though this data is not normally shaped, and you understand it's not normally shaped, it doesn't have that bell curve, but we do have 61 salaries. So our data set is greater than 30, but we do not know the population standard deviation. So the answers to these questions: not normally shaped, but n is greater than 30, and we don't know sigma, so we're going to use the T distribution. So what I want to show you now is how to find those critical values using the T distribution for this example. I'm going to do it on my calculator. The answer here is shown here, 1.671. Now, let me show you how I came up with that answer. So if you'll remember, we did this similar thing when we had to find the critical values for a normal distribution. So we're going to press second and VARS key to access the distribution menu. But we're not doing a normal distribution, we're doing the t distribution. So I'm going to toggle down to inverse t. And here, since we want a confidence level of 90%, remember then on the left and the right tail is going to be 10%. So we're going to find that value for t that has the 90% that's in the middle plus that extra 5% in the left tail. You remember that from the screencast I made from the normal distribution. So this area is going to be 0.95. Remember that. That's going to be the 90 plus that extra 5. The degrees of freedom is 60 in this problem. Remember I talked about that on the previous screen or 2 screens ago. Since we have 61 salaries, that means n is equal to 61, and 61 minus 1 is 60. So we'll paste that in there, press enter, and we get a critical value of 1.671. Okay, next question. So here we have Denver Bronco salaries. We're looking for a confidence level of 99%. Here, the population standard deviation is known. It's $3,342,000. And we have 61 player salaries. Is the data normally shaped? No. Is n greater than 30? Yes. Because these two conditions are met, we can construct a confidence interval. But since we know sigma, we're not using the t distribution, we'll be using the normal distribution. So to find that critical value, which is shown here, we're going to use the normal distribution. Now, what's that area going to be? You think about that for a minute. If you need to pause the video, go right ahead. So 99% is the area in the middle. So we have 0.01 on each side. The sum of those is going to be 0.01. And so in each side, we have 0.005. So the area is going to be 0.995. For a normal distribution, the mean is still 0. The standard deviation is 1. We want the area to the left. I'll paste that in there. And we get a critical value of 2.576. Okay, that's it. I hope you enjoyed this video. Talk to you later.